This is a lab exercise captured on video on the topic of real-time DSP taken from the Lab 7 of the Dreamcatcher ME2300 University Courseware. We are going to use the audio codec on the DE2 board to perform simple real-time DSP operations. To get the most out of it, you should view this video together with the lab sheet. Please download the lab sheet from this link. The first experiment is to create an audio loopback application by using the DE2 onboard audio codec. The audio loopback application will convert the analog input signal and pass digital samples from the ADC directly to the DAC as analog output signal without any processing. The second experiment is to investigate the quantization effect of digital samples introduced by digital sampling. Once you have completed this lab, you should be able to create the basic framework for real-time digital signal processing using Simulink, Altera DSP Builder, Courseware and DE2 board. Understand the effect of quantization in ADC and DAC. In this experiment, we will build an audio loopback project in Courseware using the schematic entry method. By using the template folder, which consists of the DE2 audio codec modules, rename the template.bdf into loopback.bdf. Now launch Courseware software and create a new project in Courseware. Select the working directory and name the project as Loopback and click Next. Add the loopback.bdf file into the project and add all the remaining Verilog files from audio core folder into the project and click Next. Under Family section, select Cyclone 2, select Fpga for package, 672 pin count and speed grade of 6. Select EP2C35F672C6 from the device list. This is the Fpga on the DE2 development board. Click Finish to complete the project. Open and examine the loopback.bdf schematic. We can notice that the ADC consists of left channel and right channel. The digitized signals from both channels are then looped back to the DAC. On the Courseware main menu, click Assignments followed by Import Assignment in order to import the DE2 pin assignments.csv pin assignment file, and you may start the compilation of the project. You should be able to see the successful compilation report. Now we are ready to program our design into Fpga. Click on the programmer icon to launch the programmer and click Start to program the Fpga. Connect an audio source to the line-in jack on the DE2 board and connect a pair of speakers to the line-out jack on the DE2 board. Play the audio. You should hear the audio streaming from the speakers or headphone. In this experiment, we will create a DSP builder model to quantize the input audio signal and then output the signal to the DAC. The signal will be quantized with different number of bits. We use the switches on the DE2 board to select the quantized signal for playback and observe the quantization effect on the signals. This is the complete design done by using Simulink. With DSP Builder, it allows you to go from system definition and simulation to the system implementation. The DSP Builder signal compiler block reads Simulink model files that are built using DSP Builder and Megacore blocks and generates the hardware description language files for synthesis, hardware implementation, and simulations. Now we are going to import the DSP Builder model into the Courseware project. After exported the Simulink design into HDL block, open the Quartz2 project file and insert the HDL block into the schematic. Click Symbol Tool icon and then select the input symbol from the pin libraries. Double-click the pin name label to rename the symbol as SW1. The label SW1 is assigned to the switch label as SW1 on the DE2 board. We will use this switch to select the output signals from the two quantization settings. Click Symbol Tool again and select the Quantization HDL module exported from Simulink design. Compile the project and then program the Fpga. Set up the audio playback, trigger the switch SW1 and listen to the audio playback. The quantization effect is similar to noise found in the signal. We can also observe the quantization effect by using an actual mixed signal oscilloscope. Use the mixed signal oscilloscope to capture the audio input and compare with the audio output after quantization. Connect the 2x8 flying leads to the DE2 board expansion header pins. These header pins are used to observe the digital data from DE2 board. Connect the MSO analog channel 1 to the right channel of line out and analog channel 2 to the left channel of line out. Input a 100 Hz tone into the DE2 line-in jack. Observe the waveforms on the MSO with slider switch SW1 in the down position. Enable the 4-bit quantization by changing the slider switch to the up position. We can notice a significant quantization effect on the channel 2 100 Hz tone. The quantization effect is similar to noise in a signal, and this type of noise is called quantization noise. We can observe the synchronization signals between the audio codec and the Fpga by switching the signal bank. By zooming to the oscilloscope, observe that the interval between the ADC-DAC enabled pulses is about 20.8 microseconds, which is the reciprocal of 48 kHz. This is a signal that indicates the ADC has captured a pair of left and right channel samples, and the DAC is ready to accept another pair of left and right channel samples. By further zooming into the waveforms, you should be able to observe that there are 16 clock pulses from the rising edge of ADC to the falling edge of DAC. You should also observe that there are 16 clock pulses from the falling edge of ADC to the rising edge of enabled signal. In this lab session, we have learned about the ADC and DAC of an audio codec and the measurement of sampling rates. We also learned the DSP builder approach of design for HDL implementation. In addition to this, we also observed the effect of quantization in a signal arising from ADC and DAC.